For today's lesson, we will have the evaluation of algebraic expression. So after this session, you will be able to evaluate algebraic expression, and also you will be able to apply the hierarchy of operation in simplifying expression. To evaluate algebraic expression simply means that we are going to substitute the variable in the expression with the given values. When we are evaluating algebraic expressions, there are steps that we have to follow. First, plug in the value of the given variables in the given expressions. Plugging in means substituting the value of the given variables to the given mathematical expressions. After the process of substitution, we can now perform the GEMDAS rule. GEMDAS is an acronym for the hierarchy of operations when we are evaluating a mathematical expressions. Remember that G stands for the grouping symbols, E for the exponents, M for the multiplication, D for the division, A for the addition, and finally S for subtractions. If the grouping is involved, we have to work on the innermost parenthesis first. After evaluating the terms inside the parentheses, it's now time for us to evaluate those terms that contain exponents. Then after evaluating the exponents, we can now do the process of multiplication and division that we usually do from left to right. Then finally, when the terms are ready to be subtracted and added, we can now do that from left to right as well. Let us now evaluate algebraic expression. For the first example, I have here evaluate 3mn minus 6p if the value of m is 1, the value of n is 2, and the value of p is 3. So following the steps that we had earlier, the first thing to do is the process of substitution. So let us now substitute the value of the variable to the given expression. So let's have 3 times the value of m times the value of n. So as you can see, I just substituted the value of m, which is 1, and the value of n, which is 2. Okay? Then minus 6 times the value of p, which is 3. Okay? After the process of substitution, the resulting expression now is a mathematical expression. Okay? So we are now ready to do the GEMDAS rule. So let's try to find out what operations do we have here. So as we can see, we only have multiplication here, another multiplication here, and a subtraction here. So following the GEMDAS rule, we're going to do the multiplication first. Okay? So let's multiply the terms. So we have 3 times 1 times 2, we will have 6, minus 6 times 3, which is 18. So this time we only have subtraction here that is present in our expression. So all we have to do is to subtract the term with the other terms. Okay, so we have 6 minus 18 is equal to negative 12. Okay, so 3mn minus 6p is equal to negative 12 when m is equal to 1, n is equal to 2, and p is equal to 3. For the next example, let's have evaluate m plus 3n if the value of m is 1, the value of n is 2, and the value of p is 3. Okay, so the first thing to do is substitution. So let's now substitute the value of m and n to the given algebraic expression. So let's have 1 plus 3 times 2. So 1 is the value of m and 2 is the value of n. So I just substituted the value of m and n to the given algebraic expression. So the resulting expression now is a mathematical expression which we need to evaluate using the PEMDAS rule. Okay, so let's try to find out what operations do we have here. So we have multiplication and addition. So following the PEMDAS rule, we have to do the multiplication first. Okay, so we're not going to do anything with 1 because there is no operation here. So let's have that as 1 still. Okay, plus 3 times 2, that is 6. And finally, we only have addition here. So let's just add the two terms. So we have 1 plus 6 is equal to 7. Okay, so when we evaluate m plus 3n, when the value of m is 1, the value of n is 2, and the value of p is 3, the resulting value would be 7. Let us now have the third example. Okay, so evaluate 6m minus 3n using the same values that we had earlier. Okay, so first do the substitution. So substitute the value of m and n to the given expression. Okay, so 6 times the value of m minus 3 times the value of n. Okay, then try to find out what operations do we have now in our resulting expression. Okay, so we have multiplication here, then subtraction here, and another multiplication here. Okay, so following again the PEMDAS rule, we have to do the multiplication first. So let's multiply first 6 times 1, so that would be 6 minus 3 times 2, which also be 6. Okay, then finally we only have subtraction here, so we just have to subtract 6 by 6. So 6 minus 6, that would be 0. Okay, so when we evaluated 6m minus 3n, the resulting value would be 0. Okay, so let's have more complicated examples this time. Okay, evaluate 2 times m squared minus n plus 2np if the value of m is 1, the value of n is 2, and the value of p is 3. Okay, so again, first we have to do the substitution. So let's substitute the value of m and n to the given expression. Okay, so let's have 2 times the value of m squared minus the value of n, which is 2, plus 2 times the value of n, which is 2, and the value of p, which is 3. Okay, so the resulting expression now contains exponent and a grouping symbols and an addition. There are also multiplications here. Okay, so let us now first evaluate the terms that are inside the parentheses. Okay, so inside the parentheses here, or the grouping symbol, we have 1 squared. So let's evaluate that first. So we'll have 2 times 1 squared is 1 minus 2. Okay, so the 2 did not change here because we just evaluated 1 squared. Okay, plus, okay, we will not do anything with the other part, so that will still be 2 times 2 times 3. Okay. After evaluating the exponents, we have now 2 times 1 minus 2 plus 2 times 2 times 3. Okay, so in this expression, let's try to find out what operations do we have here now. Okay, so we have a grouping symbol here, an addition here, and a set of multiplications here. Okay, so following the GEMDAS rule again, we have to evaluate first those terms that are inside the parentheses. So we'll have to evaluate 1 minus 2 first, okay? So that would be 2 times 1 minus 2 is negative 1 plus 2 times 2 times 3, okay? So after evaluating those terms that are in the parentheses, then we only have multiplications and addition this time. Okay, so again, we have to evaluate multiplication first. So we'll have 2 times negative 1 is negative 2 plus 2 times 2 times 3, that would be 12. Okay, so finally, we just have to add negative 2 by 12, then that would be 10. Okay, so the answer for this example is 10. In this example, we are given a rational expression which is 4m minus n all over 3mn minus 4p, and we are going to evaluate that using the same values that we had for m and p earlier. Okay, so again, the first thing to do is the substitution. So let us substitute the value of m, n, and p to the given expression. So for the numerator, we have 4 times the value of m, which is 1, minus the value of n, which is 2. And for the denominator, we have 3 times the value of m times the value of n minus 4 times the value of p. Okay, so looking at the numerator and denominators, we only have multiplication and subtraction in the numerator rather, and also multiplication and subtraction for the denominator. Okay, so again, we have to evaluate first the multiplication. Okay, so let's have 4 times 1, that would be 4 minus 2. Okay, we didn't do anything with 2. Okay, then in the denominator, let's have 3 times 1 times 2, which is 6. Okay, minus 4 times 3, which is 12. Okay, then the resulting expression now would have 4 minus 2 in the numerator and 6 minus 12 in the denominator. Okay, so subtracting them, so we'll have 4 minus 2, that would be 2, and 6 minus 12, that would be 6. Okay, so all we have to do here is to simplify the result. So getting the common factor between 2 and 6, that would be 2. So 2 divided by 2, that would be 1. And 6 divided by 2, that would be 3. So the resulting value would be negative 1 over 3. Why negative? Because positive divided by negative, that is negative. Okay? So the value of this expression is negative 1/3 when we evaluated that using the value of m as 1, n is 2, and p is equal to 3.